Hi, this is Miss Nsindane coming to you on Bridgewood Educational Services online classes. Okay, so I'll be doing mathematics for you, which is term 1, where I'll be focusing on the arithmetic sequences, geometric sequences, and quadratic sequences, which are the patterns and sequences that we'll do in term 1. Okay, so I'm going to start with the arithmetic sequence. Okay. I'm going to start with the arithmetic sequence. Okay, so I'm just going to do a proper introduction. Okay, the arithmetic sequences is another word for it is a linear. It is linear. Another word is linear. So the general term that you're going to have is Tn is equal to a plus un minus n minus 1, and then we have d here. I usually put this in brackets so that when you have to substitute the two. Okay, and then carrying on, I'm just going to give you top of my head numbers that we're going to make an example of. Let's say we're going to have a 7, and then we're going to have a 10, we're going to have 13, 16, and 19. Okay, the first thing that you need to know is that the arithmetic sequence has got one common difference. Okay, so let's try and find the common difference here. So we are going to say 10 minus 7, and then we're going to say 13 minus 10, and then 16 minus 13, and so on and so on. So when we say 10 minus 7, it's going to give us a 3. 13 minus 10 is going to also give us a 3, and so on. So we all know that the first difference, which is the common difference, is 3. Okay, it is going to be 3. So when we continue, the things we know about arithmetic is that it is linear, and then it has a common difference. So let's make an example when doing maybe so let's take the sequence that we have here, and then they say that you need to find the nth term. So when they want you to find the nth term, they want you to find the general formula. So we know that when you want to find a is equal to the first here, which is going to be 7, the first term, and then we're going to have d, which is what? Which is the difference that we have, which is 3. So we know that Tn is equal to 7 plus n minus 1, and then the difference that we have is 3. Okay, so we're going to know that it is 7 plus 3n minus 3. So what I'm going to do is just shuffle this around to make it in a proper form. So it's going to be Tn is equal to 3n, and then it's a 7 minus what? Minus 3 here, which is going to be plus 4. So this is our general term. Okay, so the next thing that is going to come, the question that usually follows this one is that find a value. You're going to have to find a value. Okay, so they're going to give you that the term is equal to maybe 15. Find the term for the 15th term. So you're going to use this formula that you have here. So what we're looking for is T15. Okay, so it is going to be equal to 3. Where you see an n, you're going to put 15. So we're going to have 15 plus 4, and then you punch that in your calculator, and then you're going to have 45 plus 4, which is also equal to 49. It's also equal to 49. So we know that T15, therefore T15 is equal to 49. Okay, and then another example that usually follows when writing in an exam paper is that they want you to find the position, whereby you have the value now, they want you to find the nth term. Okay, so you're going to have, let's say, let me just make it an example here. Let's say they say find the number of terms if the last term is 106. Okay, they say find the number of terms if the last term is 106. So we're going to go back to the general formula. You see the general formula here. So we're going to go back to the general formula. And then what we're going to say is we're going to write it down here now is equal to 3n plus 4. Okay, so we have 106, which is our what? Which is our value. What we want to find out is the n. That is what we are focusing on. Okay, so we're going to have 3n plus 4. What works here is just a simple substitution. So it's going to be 3n is equal to 106 minus 4. Okay? And then when you substitute this, it's going to be 3n is equal to 102. And then we both divide by 3 in both sides. And then we have n, which is equal to 34. So we haven't answered the question here. The question was find the number of terms if the last term is 106. And then we know that 106 is in the 34th term. So the answer is, therefore, there are 34 terms in a sequence. There are 34 terms in a sequence. Okay, so let's carry on. Let's enter into another. Let's enter to another part of the sequence. So we're going to do now a geometric. We're going to do a geometric. A geometric sequence. Going to do a geometric sequence. So as I go through, you're going to see the differences between arithmetic, geometric, and the quadratic one. Okay, so let's just have a proper introduction on the geometric. Okay, so the first thing that you need to know that it is exponential. This means that it increases rapidly, it increases very quickly. Okay, so the general formula that you usually have is Tn is equal to AR into n minus 1. Okay, so we have here an A, which is always T1, like the arithmetic, and then we have an R here. See, the previous one we had a constant number, but here we have a constant ratio. Our constant ratio is the one that we're going to have. The constant ratio, when you divide the terms by each other, you get something that is exactly the same. So it is constant ratio. It is a constant ratio. So now let me just make an example using the numbers that I have done for you. So we have a 2, we have a 3, and then we have 4, 5. Let me do this so that you'll see. And then, and so on. So here, the first term is 2, and then the R. How do we make sure that we get the constant ratio? What you do is you take T2, this is T1, T2, and T3. You take T2, and then you divide by 1, and also you're going to do what is going to say T3, and also divide by what? By 2. Okay, so since we have the values, so our R is going to be 3/2. To prove this, go and also say 4 divided by 3. And when you do that, you're going to also get the exact number, which is going to be 3/2. Okay? So we know that A is equal to 2, and then R is equal to 3/2. So now we can easily equate and say Tn is equal to 2 into 3/2 n minus 1. This is our general formula. Okay, and then now when we continue, we're going to want to find a value. So taking this equation, what we're going to do is, maybe they say the term that you need to find, UN is going to be 15. So we want to find T15. So we're going to say 2 is equal to 3/2. And then we know instead of n, we're going to have to put 15 here. And then it's going to be 15 minus 1. And then when you just punch this in a calculator, you're going to get a value which is 583.86. Now that is our nth term. That is the value of the term of 15. And then now we want to find the position using the geometric sequence. Okay, let me just take another example without using this one. So let's say they say, which term is equal to 8748. Okay, and then they gave you a general term which is Tn is equal to 4 into 3 all over n minus 1. Okay, all over n minus 1. So what we're going to do is, you already have the value, so you're going to have to say 8748 is equal to 4 into 3, and then we have n minus 1 all over 4. Okay, and then substituting, what we're going to say is, let me just do this so that you'll see. Sorry. And then what you're going to say is, you have, basically, let me go up. Basically what I did here, I divided here by 4, and then I divided here by 4, and then these two are going to cancel out. So when you divide this by 4, you're going to get a value, and then you're going to get 2187, which is equal to 3 to the power of n minus 1. Okay, so what we want to do here, we want to find an exponential form. 2187 must be in an exponential form. So you're going to put this 2187, and then you're going to press shift on your calculator, and then you're going to press the button which has effect, and you're going to get what? You're going to get 3 to the power of 7, which is equal to 3 into n minus 1. So now this is very simple going forward. So we have the decimals which are the same, so we're just going to take the exponents. So we're going to have n minus 1 is equal to a 7, and then n is equal to 7 plus 1, which is what? Which is an 8. Okay, so now answering the question, you're going to say, therefore T8 is equal to 8748. Okay, so we are done with that. And going forward, usually they give you another way of answering this. They give you another pattern whereby you give in maybe a k and a number, and then what you're going to, let me just make an example. It's a question with variables in the terms. Okay, so you're going to have, let's say they give you a sequence way of k plus 1, and then here, and then you have k minus 1, and then you have 2k minus a 5. Okay, so let me just go up. Yes, this is what we have. So from here, they say calculate the value of k and hence the possible sequence. Now the possible sequence means that they want you to find T1, the term 1, the term 2, and the term 3. So what do you usually do in terms like this? For you to find the common difference, what you would have done, let's say this is T1, T2, and T3. You would have said here, they're either going to tell you that the sequence is arithmetic or the sequence is geometric. That is very compulsory because you cannot go on without knowing that. So for an arithmetic sequence, let's say this is, let me just press N. Let's say this is an arithmetic sequence. Okay, so for an arithmetic sequence, we're going to have 1, a constant difference. Okay, I'm not going to continue there, but it's difference. As we have previously said before, you need to have a constant difference. Okay, so what we're going to do is we're going to say T3 minus T2 which is equal to t2 minus t1, okay? So we're going to have 2k minus 5 into k minus 1, which is equal to k minus 1 into k plus 1, okay? So now what you do here, you just substitute. So it's 2k minus 5, and then see the negative is going to come and multiply here. It's also going to come and multiply here. So you're going to have minus k and plus 1, which is also equal to k minus 1 minus k minus 1, okay? So it is going to be k minus 4, and then the k's are going to subtract each other, which is going to be negative 2. And then your k is going to be a 2 here, because when you transpose this, it is going to give you 4 minus 2, which is this one. So we were dealing with arithmetic, and then we're going to continue and take the exact pattern that we were given, and then do it in a geometric form. Now we're going to do it in a geometric form, okay? So now this is a geometric form, okay? So in a geometric, you're going to say t3 all over t2, which is equal to t2 all over t1. So it's going to be 2k minus 5 all over k minus 1 equal to k minus 1 all over k plus 1. And then what you do is a cross multiplication. I think you remember that in your classes, we can also do a cross multiplication. So when we do a cross multiplication, it's going to be 2k minus 5 into a k plus 1, and then we're going to have k minus 1 into k minus 1, okay? So Lana J, you just do the quick equations, and then you just substitute where you need to substitute, and you add where you need to add. So let's just do that. And then what you do here, you times this with this, and then you times this with this, then you times this, sorry, and then you need to times this with this, and also this with this. So what you're going to get is going to have 2k minus 5 minus k plus 1, which is equal to k. This is k. So when you have, it's k squared, you see, and also here, and then you're going to have here, and then you're going to have also here, okay? So we're going to say the k times the k is going to be a k, it's going to be a k minus 1k, okay? And then we're going to have a negative 1 minus 1, and then we're going to go up and substitute. And then what we're going to have, no, I think I made a mistake there. Let me just undo. Okay, so let's go up there, and then you're going to have a k times a k, which is going to be a k squared, then a k, which is going to be minus k, and then here, which is going to be minus k, and then from negative to negative is going to be plus 1, okay? And then when we continue, we're just going to take everything and put it in one side, okay? Going to take everything and then we put it in one side. And then when you do that, it is going to give you a 2k squared minus a k minus a k, and then minus 3k plus 2k minus a 5 minus 1 is going to be a 0, and then it is going to be a k squared minus k minus 6, okay? Because we have a k squared here, and we have 2k squared. The 2k squared is going to minus a k squared here. It's going to be a k squared. And then the negative 5 plus 1 is going to be negative 4. And then when you're going to substitute it to the side, it's going to give you all a negative 6. So the formula is going to be like this. And then this is all equal to a 0. And then now all you do is factorize. You factor the factors here. So I think we remember factorization. Factorization happens in two ways. It's either it's a quadratic factorization or you just factorize the way the first term that we used to do. And then we're going to have a k minus 3 into a k plus 2. How I usually find this is I say n1 plus n2 is equal to a b. And our b here, as you can see, when there is no number, it means that a b is equal to a 1, which is also, equal to a 1. So we have our n1, which is negative 3, plus 2, which is going to give us a what? And then you no. Can we cut that? Are we going to be able to cut that? Okay. Oh, okay. All right. Okay. Yeah. So what you do here, you have found your factors. So you're going to have to say k is equal to a 3 or k is equal to negative 2. So remember, we have not answered it. They said that you must find possible sequences. So since we do have our values of k, which is k is equal to a 3, and then our k is equal to a negative 2, what you need to do is you need to go back. You need to go back here. So where you see a k, you're going to have to first, where you see a k, you're going to have to first put in the 3, and then the 3 here, and then the 3 here, and then you're going to find the terms. And then when you see the k again, since we had two values of k, you're going to have to put negative 2, and negative 2. So let's quickly do that. Let us quickly do that. So if k is equal to 3, our sequences are going to be 3 is to 4 is to 1. And if k is equal to negative 2, our sequence are going to be negative 2, negative 1, and negative 3. Okay, so I think we're just done with that. We are done with arithmetic and geometric. Okay, so the last one that we have is a quadratic. The last one that you have is a quadratic. So a quadratic needs to have a first difference, and then it needs to have a second difference, okay, for you to be able to do everything, okay. And then let me just make an example. Let me put in the values that you can do. Let's say you have a 3, you have a 7, you have a 15, you have a 27, and then you have a 43. Okay, so let's find the first differences. So we're going to have 7 minus 3, which is going to be a 4. 15 minus 7 is going to be an 8. 27 minus 15 it is going to be a 12. And then we're going to have 43 minus 27 is going to be a 16. Okay, that will be our first difference. Okay, and then let us have our second difference. Our second difference needs to be a common difference in all of the numbers. So it's 8 minus 4, which is a 4. 12 minus 8, which is a 4. 16 minus 8 minus 12, which is a 4. So this is our second difference, and this is our first difference. Okay, so now let's find the general term. So we're going to, for you to find the general term, you're going to have to say a is equal to a half times the second difference. Okay, so your a is going to be a half into a 4, and then half of 4 is what? Is 2. For you to find a b, you need to say there's a general equation where you say it's 3a plus b is equal to 4, and then we already have a, which is here. So instead of an a, you're going to put in a 2. So it's going to be 3 into 2 plus b, which is equal to 4. And then our b is equal to -2. Okay, so now we need to find c. We need to find c. So for c to be able to be substituted and need to find the value, we're going to be a plus b plus c, which is equal to 3. So we already have a, we already have b. What we need to find out is what? Is c. So the 3 here comes from this side. So you just take any of the first differences. So the 3 here is the first term that you have here. So this 3 comes from there, and then your a is what? Is 2, and then your b is what? Is a -2, plus c is equal to 3. This is going to subtract each other, and then we know that our c is equal to 3. Okay, so now the general term is going to be Tn is going to 2n squared, 2n squared minus 2n plus 3. Okay, so this is our quadratic equation. So I think we're done. We did our pattern, we did all our sequences, we did our arithmetic, we did our quadratic, and then we did our geometric. So this was Miss Nsindane coming to you at Bridgewood Educational Services. Till next time.